Okay, now let us have another activity. Another activity. After this, this is video 13, I think. I'm sure it must be. So let us do the next activity. Now, learning activity 1, 3, now 2. This is what we are dealing with the matrix determinants. Still, this is what we are doing. Let us do this. So what I'm going to do is to write down. I'm going to write down this learning activity because everything has been covered during class. Let's have it. Let's have it now. This is it. Let's have it. Oh, too much ink for this marker pen. So now, alternatively, this one I don't think it works. It works. It works, but not so great. Okay. So now we are still dealing with 1.3. This is the matrix determinant. Now we are still in this section. Now what we want to do is okay. Let me do this. It is I hope this one works. So it is we are on activity learning activity. So we are dealing with learning activity 1.3.2. It is in this section in properties of determinant. Determinants. And the learning activity dealing with learning activity. This is 1, 3, 2. Okay, this is the learning activity. So let us write it down. Write this activity down here. Okay, so I have one question. First question is without calculation, predict the value of the determinant of each of the following matrices. So first matrix is matrix A, 1, 3, 2, 6. Second matrix, matrix B, this is 12, square root 3, negative 5 over 7, 0, 0, 0, 3, 5, 1, 16, negative 9. This is it. Question number 1. Question number 2. Consider the matrices. I actually have matrices. Matrix A, negative 1, 2, 3, negative 5, and the matrix B, 3, negative 5, negative 1, 2. Okay. So now some question A connected to this question 2. How are rows 1 and 2, rows 1 and 2 of matrix B obtained from the rows of matrix, from the rows of matrix A. Probably is exactly of the matrix A. B, calculate matrix determinant of matrix A and the determinant of matrix B. See, we have to, what conclusion is, what do you conclude? What do you conclude? Okay, so now this is the activity, this learning activity. This is all about this learning activity. Okay, so now let us, so if you are looking, we are watching this video, so that and you are a student, please pause or stop here and try to answer 1, 2 questions here. Okay, I hope you did it. And then now let us give answer to this learning activity. Answer to this learning activity 1, 3, 2. Okay, now looking at this, so we want to find the determinant of this matrix A. So there are many ways to find without calculating this determinant. You see the second row is twice the first row, which means automatically this determinant is equal to 0. And another way of doing it is by calculation, but by using properties. This is the same as So already it is equal to 0. We can now make a factor out, factor 2 out, and get 1, 3, 1, 3, because of the linearity. This determinant, we know it is a bilinear form. So that is the reason why I can factor out 2 in this row and get this determinant. Now here we have 2 rows or 2 columns are the first row is a multiple of, so the second row is a multiple, the second column is a multiple of the first, so we can factor out 3, get 2, 2 times 3, so determinant 1, 1, 1, 1, determinant of, you can have 6, determinant 1, 1, 1, 1, okay. Now you can use the second property of determinant is antisymmetric or skew symmetric, which means that this determinant of the same column, column 1, column 2 is the same, as well as row 1 and row 2 is the same. So this determinant is 6 times 0, so this determinant is 0, so we get 0. 6 times 0 is 0. So of course, they said without calculation, so we should calculate by just observing that the second row is a multiple of the first, like the second column is a multiple of the first twice. So I mean thrice. This is so this matrix can be written as 1, 3 times 1 and 2, then 3 times 2. So the second column is a multiple of the first. So there is another way of writing this matrix. It is 1, 2 times 1, then 3, then 2 times 3. Also, the second row is twice the first row. The second column is thrice the first column. So one of these can be used to conclude without calculating that the determinant of this matrix is equal to 0. The first factor comes from this second, the twice the second row. It is twice the first. Second row is twice the first row. Can factor out the 2. Secondly, we can factor out the 3 because the first the second column is 3 times the first column, so which is 6. But this is in case of calculation. Actually, without calculation, you calculate mentally so that you give a solution. Actually, here we have calculated, spotting out or recognizing that the second column is thrice the first. It's kind of calculation. Also, second row is twice the first row is another kind of calculation. Actually, we use mentally and we predict the determinant is equal to 0. Okay. Now next, okay, this case B is very easy because we have the whole column is equal to 0. Here means that the determinant B is just equal to 0. Okay, so we could 0 could be multiplied by any column. So to conclude, actually, that this determinant is 0. We may use also calculation, but we are restricted to not using calculation. So because they are 0, so if we calculate, so we are going to find determinant is equal to 0. So now second question. So first question is answered. Second question, consider matrix A and B. Now if we want to calculate A, how are rows 1 and 2 of matrix B obtained? Of matrix B obtained from rows of matrix A. So here, the first question A, so question A. So if we look at the second row and the first row, of the matrix A are the same. It means that they have been switched. The rows of B has been switched. It means that B is equal to elementary operation, the first type of elementary operation times A. So first elementary matrix, so meaning that the determinant of B is equal to product E1 times determinant of A. And this is switching property of switching rows, any two rows of a matrix. So the determinant, it is a permutation matrix in which for which the determinant is -1. So we have -1 times the determinant of A, which means that both determinant A and B are opposite to each other. Of course, this is not the way the activity, this is running activity. We maybe they don't know this property. Matrix E1 here is elementary operation of type 1. Elementary row operation, elementary row operation matrix, elementary row operation matrix of type 1. Type 1 here means that you switch two rows. So the determinant of that elementary matrix must be -1, as we point out. This is the same as the switching row for the switching column elementary matrix also. So you multiply on the right side, and it is another matrix. But it is another matrix which is opposite to the original. The determinant is opposite to the original matrix. We have called this in our classes. That was the matrix F1. We called it F1 type 1. So switching column, and when we want to have a matrix, suppose the X matrix, and we can form another Y matrix, which is equal to when we switch two columns of matrix X, you get matrix Y. And now the determinant of this matrix is also equal to determinant of X times the determinant of this F1. Here F1 is the elementary column operation matrix. In that case, is also equal to determinant of X times the -1 also. So we did it in our class. There is no problem. Students know that this determinant is -1, as well as in our case A, where the determinant, this matrix determinant -1. Okay. Now, so we didn't have this question in question 1. So we have this one. So now next, let us talk about now. Let us talk about now question number 2, because everything here, this is done and this is done. Question. Now this sub question, let us now talk about B. Calculate determinant A and determinant B. Okay, whatever it is, determinant of A, we have to calculate it. We take -1 times -5 is 5. Minus 3 times 2 is 6, and the determinant is -1. Okay, obviously, if the calculation is correct, so the determinant of V is going to be 1. So let us look at it. That will be 6 times 2 is 6, minus -1 times negative 5 is 5, and then result is 1. So we see in this case these two determinants, they are the opposite to each other as it was predicted in the according to these properties of row switching. Okay, now so we have come to answer this. So conclusion is, that is the conclusion. It means a determinant of A and determinant B are opposite to each other. Okay, I think that this is okay. Now we can move to application activity in the next video. Thank you very much.